This is part 1 of 2 on chapter 12. This chapter is looking at chemotherapy, so elements of chemotherapy. So this chemotherapy, so we're going to be looking at antimicrobial chemotherapy. This is where we administer a drug to an infected person. And this drug, we give it to that person to help destroy the infective agent without harming the host cell. So these include antimicrobial drugs. These drugs can be produced naturally, or we can produce them synthetically in industry. So the origins of antimicrobial drugs. So we have antibiotics. Antibiotics are actually very common metabolic products of aerobic bacteria and fungi. So antibiotics originated from living things. So examples, bacteria in the genre Streptomyces and Bacillus produce antibiotics. Molds in the genre Penicillium and Cephalosporium produce antibiotics. So Penicillium, that is a type of fungus or mold that produces penicillin. For example, Streptomyces bacteria produces streptomycin. So these antibiotics, their original purpose was to inhibit the growth of other microbes in the same habitat. So these antibiotic producers, they produce the antibiotic to keep other organisms away so they have less competition for nutrients and space in that area. So they're just natural products produced by living things. And this image shows a mold, and that blue liquid that's coming out, that's an antibiotic that's being produced by this mold. So these drugs that we're going to be looking at, the antimicrobial drugs, we really want them to be selectively toxic. So this goes back to the very first slide. So we want drugs that will kill or inhibit the microbial cell. So we want to kill or inhibit the growth of the infection without damaging the host cell. So a lot of these antimicrobial drugs, they work against prokaryotic cells, so like bacteria cells, and they don't really work on eukaryotic cells, which are the type of cell that we have and other animals have. So we want drugs to work against the prokaryotic cells. So there's different spectrums of antimicrobial drugs or antimicrobiotic drugs. And hopefully you kind of picked up on these terms in the last chapter. But a spectrum is just the range of activity of a drug. So some drugs are narrow spectrum. So they're effective on a small range of microorganisms. So we can have like gram-positive drugs, gram-negative drugs. Those are both narrow spectrum drugs. So narrow spectrum drugs, they target a specific cell component that's found only in certain microorganisms. So gram-negative drugs, they target that gram-negative cell wall. Gram-positive drugs, they target that gram-positive cell wall. So they only work against gram-positive bacteria. Other drugs are broad spectrum, where they have a really big range of activity, and they target cell components that are common to pathogens. So a lot of times they're going to target ribosomes, for example, because prokaryotic ribosomes have a little bit different structure compared to eukaryotic ribosomes. So mechanisms of drug action, we kind of looked at this a little bit in the previous slide. So some drugs, they work against cell walls. So I'm up at the top left-hand corner. We have cell wall inhibitors, where they block the synthesis or repair of the cell wall. So these include different types of drugs. You don't have to know specific classes of drugs and what they do, but for example, penicillin inhibits cell wall production. You can have drugs that work against the cell membrane, where they cause the cell membrane to lose its selective permeability, so the cell is no longer able to regulate what goes in and out of the cell. The third way drugs can work is by inhibiting the DNA or RNA, so you can inhibit DNA replication, you can stop transcription, for example, so you can stop the DNA from being transcribed into the mRNA. It can inhibit certain enzymes that are used in replication or transcription. The fourth type of action, so now I'm on the top right-hand side, you can inhibit protein synthesis by acting on ribosomes. So again, like I just mentioned, ribosomes in prokaryotic cells are a little bit different than ribosomes in eukaryotic cells, so you can specifically target prokaryotic ribosomes. So you can target the large subunit of the ribosome or the small subunit of the ribosome to stop protein synthesis. And then the fifth way drugs can work is they can work on metabolic pathways or products of these pathways. So they can block pathways that are essential for cell growth or reproduction, or inhibit these pathways, slow them down. So here we're just going to quickly go through examples. So one, you can inhibit the cell wall. So if you expose a cell to penicillin, so we have a normal cell on the left, you expose that cell to penicillin, it causes weak points in the peptidoglycan, the cell wall, and that causes the cell to burst open. So the membrane breaks, the cell lyses, it's no longer alive. The cell membrane, you can have drugs that look like the phospholipids. These drugs will insert themselves into the cell membrane and then cause that cell membrane to break apart. So we have a green drug here, so polymyxin B. That drug inserts itself into the cell membrane, and you can see the cell membrane basically just falls apart. DNA and RNA, the DNA, you can stop DNA replication, or you can stop transcription, so that DNA cannot be transcribed into mRNA, and then that mRNA cannot be used to make any proteins. Protein synthesis, again, you can stop protein synthesis in a lot of different ways. Usually we target the ribosome, which is that structure that synthesizes proteins. So you have different types of drugs can do different things. And then metabolic pathways, you can shut down metabolic pathways using different drugs, so that you will not get the end product that you need. So just a survey of major antimicrobial drug groups. There's a lot of drug groups, and they go into details in your book. I'm basically just going to be looking at more the general. So you have antibacterial drugs. These are drugs that work against bacteria cells. So you can have antibiotics that are naturally produced or synthetic drugs that work against bacteria. Antifungal drugs work against fungal organisms, so the fungi, the molds, the yeast. Antiprotozoan drugs works against protozoans. Antiviral drugs work against viruses. So pretty much it tells you what they do in the name. There's about 260 different antimicrobial drugs classified into 20 different drug families. And if you're really interested, you'll probably take pharmacology later on, where they'll actually get into those drug families, and you'll have to memorize them all and know what they do. But this is kind of just an introduction to the different types of drugs. Antiviral chemotherapeutic agents, I want to just look at those a little bit. So antiviral, they work by selective toxicity. It's really hard to get drugs that are not going to cause damage to the host. So this is why it's really hard to get viral drugs, or things like HIV, for example. They have to take the drug cocktails, and then the drugs they're using to kill the virus affects the person as well. So there's a lot of side effects to antiviral drugs. And this is due because viruses are obligate intracellular parasites, so they have to live in a host cell. So basically you have to kill the host cell in order to kill the virus. Some drugs, they will block penetration into the host cell, so some drugs will prevent the virus from getting into the host cell, and then the virus will die because it doesn't have a cell to live in. Other drugs will block replication, transcription, or translation of the viral genetic material. So these are nucleotide analog drugs. And then other antiviral drugs will prevent the maturation of the viral particles, so they'll prevent the viruses from being put together. So protease inhibitors, these are used for people that have HIV. And again, these drugs, they cause a lot of damage to the host just because of the nature of the virus.